Hi, so today we're going to be talking about linear inequalities with one variable, and in class we were talking about just basic inequality symbols. Now we're going to talk about how we solve inequalities. And you solve inequalities just like you solve basic linear equations. So if I look at this inequality right here, the first thing that I do using addition and subtraction, multiplication and division is I would distribute the two. Okay, I would distribute the 2, just like I would if this were an equation. So I would get 2x plus 6 is greater than 4x minus 7. All right, then I balance the equation. Now, here's the one thing I keep saying. You always want the x on the left. So you have a couple options here. You can bring the 4 over, or you can bring the 2 over. So I'm going to do what I would normally do. I always bring the smaller to the larger so you can see what happens. And then I'm going to add 7. So that gives me 13 is greater than 2x, and then I divide by 2. So I get 6.5 is greater than x. The problem is we want the variable on the left. So I'm going to flip it around. So x is less than 6.5. And remember, I said that we always read it based on where the variable is. All right, so if I draw a solution, a graph of that, that means that here's 6.5. I put an open circle at 6.5. And I want all of the answers that way. So that means every number below 6.5 is a solution to this inequality, making it a true statement. We also could, do multiplication and division. So you might notice that we have fractions here. And I actually decided instead of clearing fractions right away, I was going to bring the constant to the other side. So I saw that 4. So I'm going to bring the 4 to the other side. So I get x over 2 is less than or equal to 16. All right, so now I'm going to clear fractions by multiplying both sides by 2. So 2 here and 2 here. And that gives me x is less than or equal to 32. All right, so that means that every number from 32 down, closed circle, is a solution, making this inequality a true statement. Okay, let's try the next one. Okay, I see the same situation. I see that constant. I'm going to bring it to the other side. So I get 2x is greater than 10, or 2/3 x is greater than 10, and then I'm going to clear fractions. So I'm going to multiply both sides by 3. So 2x is greater than 30, and x, if I divide by 2 on both sides, x is greater than 15. All right, so that tells me my answer. I have 15. I want x is greater than that. All right, how can I make this a little bit harder? Okay, well, first let's talk about what the opposite of 2 is. Hopefully you're saying the opposite of 2 is negative 2. And the opposite of x is negative x. But what's the opposite of addition? I hope you're saying subtraction. And the opposite of less than, I'm going to go with that the opposite is greater than. Okay? And there's a couple schools of thought on it. And the reason I'm talking to you about this is because what happens when what happens when there's negatives that get into our equation? So here's what I mean. First, I look at this, and I'm gonna distribute the negative 1/3 in this case, just to show you. So I get negative 1/3 x plus 3 is less than or equal to 12. All right, so then I subtract 3 to both sides. So I get negative 1/3 x is less than or equal to 9. All right, now I would clear fractions, but I need it to be a positive x, don't I? So instead of multiplying by 3, I'd be multiplying by a negative 3. Okay? So as soon as I've done that, I'm multiplying by a negative, I have to take the opposite sign of the inequality, which means I have to reverse the sign. So that's going to give me x is greater than or equal to negative 27. So anytime you multiply or divide by a negative, you have to reverse the sign. All right, let's try another one. I see a negative in front of the parentheses. That does not mean multiply. It means that you have to distribute. It doesn't mean you multiply 2x to 7x. You have to distribute a phantom negative 1 through. So 2x minus 7x plus 6 is greater than 4. Okay, then I combine the like terms. So that gives me 5x plus 6 is greater than 4. Negative 5x is greater than 4. So then I subtract 6 on both sides, and we get negative 5x is greater than or equal to negative 2. All right, so in this case, I'm dividing by a negative 5 on both sides, And remember, when we divide by a negative, we have to take the opposite direction of the sign. So I have to flip the sign of the inequality. So x is less than 2/5. Okay, now how do I draw that? How do I graph that? I graph that by going to 2/5. I have an open circle because it's less than, not less than or equal to, and I want all numbers less than that. Those are some basics on solving equations, okay? So let's review that rule. I like to have that rule really formalized. When you divide or multiply by a negative value to an inequality, you must change the direction of the sign of the inequality symbol. So if it's less than, it will change to greater than. If it's greater than, it will change to less than. And that's something that we just really have to be comfortable with. Okay, so now right below this, you'll see that there are 6 practice problems. I'd like you to solve each of these, and then I'd like you to check your answers. Okay, so I'm going to give you the answers now, but I want you to check them afterwards. So for the first one, the answer, r is less than 10. For number 2, y is greater than a half, greater than or equal to a half. Number 3, I got k is less than or equal to a half. For number 4, I got a is greater than or equal to negative 25. For 5, I got that m is greater than or equal to 5. And for 6, I got z is less than 13. Now, I want you to try these problems. Make sure you get those inequalities. And if you don't, bring them in for questions tomorrow in class. All right, guys, have a great day.